Hi everybody, we are reviewing the last way of solving systems of equations, and after that we're going to do some fun stuff for the rest of the year. So this is your last kind of hard thing to do, and it shouldn't be that hard because it's a review. Alright, let's get on to it. So your central question, how do you know when to solve a system by the elimination method? Okay, so here's our first example, and you'll notice unlike systems that we solved using substitution, neither one of these equations has a variable already solved for. But what they do have is that they are in order, the same order. So you have your x terms first in both equations, then your y terms, then your equals, and then your numbers. So this means this is a really good one for using elimination. So I'm going to go ahead. Oops, I'm going to go to black. Okay, so what you want to do with elimination is you want to eliminate one of the variables. So you always start by looking to see, do you have opposites already? Opposites, remember, add to 0. So you're looking for terms that are going to add to 0. And if we look here, the y's, we've got a positive y and a negative y, they all add to 0. So that means this is ready to be added up already. So I kind of box those off to show, okay, those are my opposites, draw my line through, and now I add my equations. So 1x plus 2x makes 3x on the left equals 9 on the right. Real easy to solve now. Divide by 3, x equals 3. So remember, you're not all the way done. As always with the system, you're looking for a point where the two lines cross. So now I want to just take the simpler of the two equations. I want to take that top one. And it doesn't matter which one you use, they'll both work. But just try to keep your, try to be easy on yourself and just choose whichever is the simpler option. So if x is equal to 3, we're going to replace x with 3. We still have the plus y equals 5. I'll subtract 3 from both sides and get y equals 2. So our solution is 3, 2. Okay, but earlier in the year we learned that we're not always going to have opposites already ready to go, and that sometimes we're going to have to multiply one of the equations to make opposites. So this would be an example of that. We don't have opposites with our x's, and we don't have opposites with our y's either. So then you need to think about, well, what's the easiest way to make opposites? Which one of these would involve the least amount of work to make opposites? And in this case, it would be with the y's, because you already have a positive 10y. You could easily make a negative 10y out of the negative 2y here in the red, if you just take the equation and multiply it by 5. So that's what we're going to do. So you have to multiply that entire equation by 5. So let's rewrite this. We're going to keep the first equation unchanged. And the second equation, we're going to distribute that 5 all the way through. So that gives us 15x minus 10y equals negative 35. Now we can add those up because we have our opposites here. We have positive 10y and negative 10y. So 5x plus 15x makes 20x is equal to, let's see, the negatives are going to win, and the negatives are going to win by 20. Divide by 20 on both sides. You get x is equal to negative 1. So remember, you're not done yet. You found the first coordinate. You've got to go back and find the second. So I kind of like that top equation best. The 5x plus 10y equals 15. I'm going to put negative 1 in as my value for x. So I have 5 times the value of x, which is negative 1. Plus 10y equals 15. So 5 times negative 1 makes negative 5, plus 10y equals 15. Add 5 to both sides. We've got 10y equals 20. Divide by 10. And you've got y equals 2. So our solution is negative 1, 2. Let's do one more just to really get you in the swing of things. So again, we don't already have opposites. We need to make opposites. It looks like the y's in this case will be the easiest one to make opposites out of. We have a positive 6y in the blue. If we multiply negative 2y by 3, that's going to make it negative 6y, and then we'll have opposites. So let's do that. We have to multiply the whole equation, though, by 3, not just the term we want. Okay, so we're going to keep that top equation. And then the new bottom equation, 3 times 5x is going to be 15x. 3 times negative 2y is negative 6y. Equals 3 times 14 is, what is that, 42, right? Okay, so we have opposites with our y's, and when we add up our x's, 3x plus 15x is 18x, equals, the positives are going to win, and they're going to win by 36. Divide by 18. And use your calculator on this. 18 is going to go in there 2 times. So our first coordinate then is 2. I like the top equation again. So let's use, we've got 3x plus 6y equals negative 6. Again, it doesn't matter. You could use either one. Just do your work carefully and correctly, and you'll be fine either way. Okay, so 2 times 3, that makes 6. Plus 6y equals negative 6. We're going to subtract the 6 ones, so minus 6 on both sides. We get 6y equals negative 12. Oops, 1. And then divide by 6. So we get y equals negative 2. So there's our final answer. Okay, so I've got a very short practice for you. I'm just going to give you 4 problems of this just to kind of finish off. Take a minute in your notes and answer the essential question. So just kind of a review of that is when you have equations that are in order and are not already solved for a variable. That's when it would be a good time to use the elimination method. So write that down.